My name is Paul Ruth from RINC, a research institute at UNC Chapel Hill. I'm the PI of the Fabric project. As you'll see, it's a pretty big project. It has a lot of pieces, a lot of moving pieces, and can do a lot of things for you. Some of you probably have heard about it before. Hopefully, we'll get you started using it today. I'll start off by saying we have in here, and I'm going to drop these into the. Let me see, how do I cut and paste these the best way? Maybe Charles, can you cut and paste those and drop them into the Slack? I have my screen set up such that that's too hard. So we have two bit.ly links here. One of them is a link to these slides. If you want to follow along and go back and forth, there's some links and information that you might want to get, especially for like the more hands-on pieces. So go to those slides. And the other one is a sign-in sheet. It's just a Google form that you can use to tell us like basically what Fabric account is yours and who you are. And what's going to happen is in the background, we have people that are going to be approving your accounts and adding you to a project so that you can actually use the system today. You might want to try to do the sign-in early so that they can have more time to like work through any issues we might have creating accounts. Yeah, that's the key is sign in earlier. We'll get to it more in detail, but just because I had you do it early, there's a couple things you need to know about creating an account. If you go to the portal, which you'll see once you click on that sign in link, there's a link to it. And you click in the sign in button. We use like CI logon and InCommon and with a federated identity. If you find your university in the list, you should use that. That's the easiest way. It'll be automatically approved. You don't have to do anything else. Thanks, Charles. Those are the links now in the chat, so you should be able to click on them. If you don't see your name in the list, you can use like Google identities or Microsoft identities and a few other things. If your university uses Google for its email, you can use the Google identity and log in with your university identity. If it's Microsoft, the same thing. Those are the second most preferable ways to do it. If you see your university use it, if not, try to use whatever your university uses for email. And the third way we would recommend, if none of that stuff works, use just a regular Google personal account. That should also work. One note to make is if you do use Google or Microsoft or any of those things, it actually takes you to a workflow where you have to create a ticket and somebody has to approve it manually rather than automatically. We do have Kamal who's in the call watching this, and she will be approving everyone as you do it. So try for that. Kamal will help you out. Hopefully we get everyone set up. All right. So now that everyone's doing that and not paying attention, I'll get started. But it should be all right. Yeah, so I'm Paul Ruth from RINC at UNC Chapel Hill. I'm the PI of the Fabric project. We have with me Charles Carpenter, who is from University of Kentucky, and he works primarily on the measurement framework part of Fabric. And what we'll do today, we have a hands-on piece, which is, we have an overview, which is kind of what is Fabric, why would you use it, why are we building it, what is it good for, a little demo / hands-on piece. Hopefully everyone can get an account and do some of the basic interactions with Fabric. We won't get anything too crazy because, these are brand new users. It takes a little bit to learn how to use this. But I will show you how to run some simple experiments and run a simple wide area experiment. And then we'll wrap it up with Charles talking about the Fabric's public metrics and how you can get data about how people are using Fabric and bandwidths and that kind of thing. So that's what we're going for, about an hour for each section. So Fabric was funded originally in 2019. We completed the construction phase. We're completing it now. We entered operations a year ago. We will continue in the operational phase under the current funding until 2027. So we have funding for a few more years. Hopefully there'll be more funding after that. We've been in business. I've been open for business for about the last year. We've been gaining lots of users and lots of exciting research projects. Fabric is led by myself, Paul Ruth, the PI, in collaboration with a lot of other organizations, but the primary ones are University of Illinois, University of Kentucky, Clemson, and Department of Energy's Energy Sciences Network. Dozens of other institutions that contribute resources and circuits and all sorts of things. Too many to list, but I'll show you a slide with a bunch of logos in a minute. So what is Fabric at the highest level? Well, Fabric is a mid-scale research infrastructure that empowers researchers to securely prototype and validate really disruptive network designs in an environment that closely emulates the real systems that drive their modern distributed applications today. You can think of Fabric as a scientific instrument or really a laboratory that enables experimentation with really novel paradigms for distributed applications, internet protocols, things like that, that run both across the network, but also within the core of the network. And that's really the key, is that within the core of the network piece. So it's composed of 35 distributed sites, 30 domestic sites funded by the original Fabric Midscale RI1 project, 4 international sites funded by the FAB IRNC award. And there's one special site that's a traveling site that is paid for by Siena. We actually take that to different conferences and have it looped into the testbed for the conference. You'll see it at Supercomputing if you're there in a couple months. It'll be in the SciNet, inside of SciNet, and you can use it from your booth if you like. So the primary capabilities of Fabric is to provide users with really deep in-network programmability, but distributed around the globe and connected to each other with dedicated optical links, while being integrated with all the real facilities and researchers and scientists and things that people already use. So including like HPC centers, cloud and wireless testbeds, commercial clouds, campuses, labs, large instruments, the internet, things like that. It has a worldwide footprint that's 35 sites interconnected by dedicated network capacity. The blue links in this map are typically 100 gigabit per second connected links that we control, and the orange ring there is 1.2 terabit per second. Now you probably wouldn't use all of that yourself, but we have enough capacity we can give everybody a lot of bandwidth without you interfering with each other's experiments. Each location here, so each blue dot is a small cloud, like one rack of computers, where experimenters can deploy like private routers, switches, things like that, alongside traditional compute and storage, augmented with accelerators like GPUs, FPGAs, programmable NICs, NVMe drives, these kinds of things. These user-controlled resources are then connected with network circuits between the sites and dedicated to the user. So you can think of Fabric as a research cloud that also provides access to really low-level programmable network resources inside the core of the wide area network. So that's the key. Other important things on this map are we connect to a bunch of different facilities. So there's a bunch of orange stars on the map that are different external facilities we connect to. Things like TAC, NCSA, MGHPCC, Pittsburgh Supercomputing Center, Lawrence Berkeley National Lab, places like this, as well as other test beds like Cloud Lab, Chameleon, Cosmos, Powder, National Research Platform, Sphere, things like that. They're all connected to us. So you can use Fabric as the core of the network and then experiment with all of these external facilities connected in. Notably, we also we work with Internet 2 and use their Cloud Connect service to allow you to connect your Fabric experiment directly to AWS or Google Cloud or Azure. So you can incorporate public clouds as well. We also have an international aspect. So we have a site at CERN where the particle collider is, at University of Amsterdam, University of Bristol, and University of Tokyo. And each of those sites has a special service that they provide that is a reason why we went to those locations. So there's a lot of stuff going on, connected to all the real things that you already use. It's pretty amazing. Starting to think about how much work it was to put all that together and maintain it all. This set of logos here are all, not all, but most, I think I've probably forget somebody, organizations that either like host our resources, give us network circuits across their facilities, or are some external facility that integrates with us and is accessible via Fabric. So why are we doing this? So as I've kind of pointed out, Fabric connects all the facilities, campuses, services that everyone uses for their research computing today, but it connects them with these programmable networks. But this is sort of an evolution of this. There are many pressing new distributed applications and research areas that are demanding new types of research infrastructure and new ways of sharing and communicating data. So if you think about it, like networking just in general is being transformed from connecting individual places and applications to supporting massively distributed applications that sort of naturally flow through the edge to the cloud, across the computing continuum. So these applications connect scientific facilities, instruments, big ones, small ones. They enable interaction with the edge of the network. You have cyber physical systems. You have all sorts of things like that. AI is now everywhere. You have big HPC centers that have lots of GPUs for doing AI, but everything all the way down to the phone in your pocket is doing AI, right? So the challenge going forward is one, like, can we get GPUs to do AI? Yes, in big centralized places, but it's not limited to that. We also need to like figure out how to safely and efficiently collect the inputs, the data that inputs all these models, and processes it, and then distributes the results to like omnipresent AI that's all over the place, including in your pocket, right? So there's areas like federated learning that are developing ways to preserve privacy while maintaining the benefits of AI, and these are going to take advantage of doing things both at the edge of the network, in the core of the network, and in the big cloud and HPC centers. And all of this kind of revolves around a bunch of workflows that more or less stage the ingest of data, process the data, and distribute the data, and have to decide where is the most efficient place to do each one of those steps. So these are all formidable challenges, and we can accomplish a lot of this today. A lot of it's the result of really powerful resources and tools that we've built over decades. So we have instruments, data centers, public clouds, campuses. We have all sorts of compute power and networking power within these places. They're all great, but the reality is that the core of the internet is designed to store and forward packets. It's just, that's all it's ever done. That's what it does today, and that hasn't changed. So applications are limited to running at the edge of the internet. Protocols can only be optimized from the edge. But there's this growing emphasis on edge core cloud paradigm where applications run just across multiple facilities and platforms. And currently we're limited to running this and experimenting with this on the edge. But a growing footprint of distributed data and compute means we need to scale up or re-optimize the core of the network for more distributed points within the network to do this computation. So another way to think about this is that there's really advanced capabilities in all of these edges right now, in the instruments, data centers, public clouds, but we don't yet have them in the core of the network, and this is just a limitation imposed on us. I'll just skip over that. So towards this goal, Fabric allows us to run applications anywhere, at the edge of the network, in the cloud, or in the places where routers and switches are found today. This enables network processing and intelligent caching of data, distributed AI, and many other uses that are really, really difficult to predict, but like soon will be commonplace. Hopefully some of you will invent some of them and it'll be really amazing. Fabric scales both in geographic size and performance. So we mentioned we have like 35 sites connected with mostly 100 gig or faster dedicated layer 1 circuits. It also connects the real facilities that you use, the NSF clouds, testbeds, access compute clusters, things like this. If you have a facility or an instrument or something at your campus you want to connect, let us know. We're always interested in adding more things like this. So Fabric is really intended to be a sandbox to create isolated experiments where you can be really disruptive and you can do things that you wouldn't otherwise be able to do on the public internet. You do it in the core of the network. You can be a little bit loose with some of your security because we isolate you, but at the same time, we allow you to connect to the real facilities and real users that you already support. So it's a safe place to do these wide area, really disruptive experiments, and you can deploy a topology, find out if it works or doesn't, bring it down, and fix it and redeploy it really quickly. So this is a really quick place to test your ideas and deploy them again and again. It's not really a place to like where we're going to replace the tools you already use. It's really a place where for you to prototype new things that you might want to do in a more production environment. So we do scale to the production scale, but the idea is that we want to have you invent new tools and applications that will sort of eventually be integrated into the real production systems that are out there. So what is the impact this will have on cyber infrastructure? Well, Fabric is going to makes the previously unthinkable possible by enabling access to programmable network core, empowering academic researchers. So the next generation of computing will be unbound from any specific compute resources. Applications will natively run across platforms and domains, while including smart in-network processing and computing. We kind of expect the current users to invent a bunch of novel in-network applications and capabilities that will eventually get deployed into the real production systems. We also, like, beyond doing just experimental tools and applications, Fabric is a great place to do full-scale prototypes of disruptive technologies. So it doesn't really have to be like a research project. It can be like you trying to test out a really a platform that you would like to deploy on a real production system that you have. And like many times, these risky or really expensive ideas like never really see the light of day. It's especially true if this requires disruptive changes to your campus cyber infrastructure or just the core of the internet. And what Fabric lets you do is deploy these prototypes at scale in a secure sandbox connected to real facilities, real users, and then measure the success of it and measure how valid this new idea is. And you can use that measured validation to justify to the people that might otherwise be a little worried about such a disruptive technology. Fabric also affects workforce development and just learning in general. So the ability to operate high bandwidth, wide area networks is a really sought after yet rare skill in academic environments. So many people that work with ESNet or Internet 2 or on projects like Fabric have these skills, but it's really difficult to learn these skills from a book or a virtualized environment. So Fabric provides a platform for deploying these custom wide area network topologies connected to real end systems. And it allows users the unique opportunity to learn and operate these deeply programmable networks in a real way. So it combines programmable edges with at-scale programmable core, enable hands-on experiments for training the next generation of CI engineers with minimum impact on production networks. So you can learn all these skills without actually having to spend, a decade on a job working for Internet 2 or ESNet. So the design and architecture. So here's the map I showed you before, just a little refresher. We have 35 racks of computers in various places around the world, most of them in the US. This is where you get virtual machines, but those virtual machines are connected to devices that they have full access to. So typically the device will be a PCI device. It'll be passed through to your virtual machine with PCI pass-through. So you have full control over your SmartNIC, your FPGA, your GPU, that kinds of things in the site. Then those things, like many of those PCI devices have network ports on them. Many of them are 100 gigabit per second network ports. And those can be connected to each other, no matter, like, regardless of where the actual VM in the device is. So we can connect, a FPGA with a 100 gig NIC on it that's in New York. We can connect it to one that's in Los Angeles and give that experiment the ability to use a 100 gigabit dedicated link between those two sites. And then you can build upon that, and you can make really complicated topologies that will support your whatever experiment you're trying to do. So we control the racks of computers. They're small little OpenStack clouds. We control the network links and can plumb them together. We also can connect to Amazon, AWS, and Google Cloud if you want direct connections into them from something you have in Fabric, or we can connect to the different other test beds you may have access to. It's a lot of people use Chameleon and Cloud Lab because they're similar test beds. You can easily get compute nodes on Chameleon and Cloud Lab, or network infrastructure in Fabric, and connect them all together into a big experiment where you have a core of a network and you have like data center, a synthetic data center that you've created on Chameleon or Cloud Lab. And then also we connect to various supercomputing centers. These are more like if you have an experiment you want to do, you can work with you and the supercomputing center to figure out what to connect directly to, whether it be a data transfer node or some specific instrument that you have for yourself. Yeah. The hardware. So what does it look like? So it's pretty standard, just Dell machines. They're pretty beefy though. So each of the nodes we have are 64 cores, two sockets, 64 cores, 500 gigs of RAM. Of course, you're sharing that in a VM. You're sharing it with other people. When we allocate a VM to you, we do not oversubscribe the cores. So if we give you a core, we're ensuring that that core is kind of reserved for you. There's GPUs. They're not the fastest GPUs, but they're definitely in very unique locations. So if you need GPUs at the edge of the network or in the core of the network, there's not too many places you can go get that, especially distributed as wide as we are. There's 1 terabyte NVMe drives in the servers. You can have those connected to your VMs with PCI access, so you have full control over it. Each site has 250 terabytes or a quarter of a petabyte of storage in each site. So we have 35 sites. So do the math there. That's a lot of storage. And you can get a volume on this storage that you can mount over the network from your experiment. We have network ports. They're mostly 100 gigabit per second network ports. Some of them are 400 gigabit network ports. There's Tofino-based P4 switches. There's not too many of them, but there's a handful of them that are in there. Reconfigurable network cards. So we have a bunch of FPGAs. Like there's almost one in every site. There's a few sites that don't have them. And these are Xilinx U280s. And there's 2 different groups that have support for running P4 applications on the Xilinx cards. It's pretty exciting. So if you're looking for P4, place to do P4 at high bandwidth in the wide area, this is a good place. We have lots of Mellanox cards, ConnectX 5s and ConnectX 6s. They all have hardware offload. People do P4 with like DPDK and they can program the NICs and you get full access to the NICs. It's pretty good. Multiple interface speeds. You can, if you don't want 100 gigabits per second, we also have 25, but those are our slow ones. So if that's too fast for you, then you'll have to do something to artificially slow it down. Lots of kernel bypass and hardware offloading using DPDK, FPGAs, GPUs, this kind of stuff. That's kind of what we're looking at. Each of our sites, we call our sites hanks because the whole thing's fabric, and a hank is a measured unit of coiled or wrapped yarn or twine. So like if you're into knitting, you might buy yarn in a hank. Some people probably know that. So we call each of our sites a hank. What our sites are is a stack of these Dell, like just regular Dell servers. The key feature though is they're just packed as full as we can make them with these PCI devices like GPUs and FPGAs and everything. So these are they have lots of PCI devices in them. And what happens is you create a VM on the site. It'll like a regular VM, it'll be connected out the management switch to the internet. And then we will add these PCI devices to your VMs via PCI pass-through. If your PCI device has a NIC on it, it is connected to the big data plane switch, and what you can then do is get this VM, all these devices, and you can tell the system to plug those devices into each other dynamically, and we have software that does that for you. At the same time, there's some P4 switches. They are also connected to a switch. You can access those. They have a VM on them that is the way you access the P4 switches. And there's a bunch of spinning storage that you can have volumes on, and you can mount that. So basically, we're OpenStack cluster, but it's a hybrid virtualized bare metal mode where you can get virtualized compute and memory, and then you can combine that with PCI pass-through devices that you completely own that hardware. So how does it kind of look? So you can deploy these VMs across the whole, all the fabric, and decide where you want to put them. You can decide which VMs have which type of devices. They can have a mix of devices or all the same devices. It's kind of up to you. And then you can tell the system to plug the different network ports on the different devices that you have into each other, regardless of how far away they are from each other. And you can have things where, maybe a device has 3 or 4 NICs in it, and it can behave like a switch or a router, or maybe you have an FPGA that has 2 100 gig ports on it, and it's just a bump in the wire that's processing some packets using P4. And you can also connect it to external things like maybe a machine you have in your lab, or like a big supercomputer, or one of the other cloud test beds like Chameleon or Cloud Lab. This is kind of another, like once you've built your topology, an interesting thing to do is connect external things to it, and now you have what essentially looks like an internet at scale that's connected to a bunch of different external facilities. Now, I show this picture a lot, and some people get a little overwhelmed, like, oh, this is like, that's not what I'm looking to do. This is kind of like the biggest type of an application that people would do. Plenty of people do small things where they just have a few VMs that are connected together, and they test how fast something is. And the example that we'll have you do today is kind of a smaller thing that you can build on. So this is just like the big, huge, like pie in the sky examples that we try to get people to do. Example use cases. So we have a few here. These aren't that I like. There's some of my favorite ones. So this is a really interesting one because this is Fabric doing biomedical engineering. So at Rutgers University, they have a cryo-EM microscope. So I'm not really sure what it is, except it's a microscope that's cold, and somehow that's better. And but it's basically a big device that they need to control remotely, and it produces a bunch of data. So it's connected directly to Fabric, and what they have is something they call a cloudlet, which is a packaged piece of software that they can deploy on Fabric. And they deploy it on Fabric. They connect it to their microscope, and now they can control the microscope, and they can extract the data off the microscope and send it to the Pittsburgh Supercomputing Center. And when they do that, they can access the supercomputers there and process the data, send it back to wherever it needs to go. So this is one of the use cases that we have. This one, they actually wrote a paper. They got the best paper award at PERC earlier this year. So it's kind of an interesting example that we like to highlight. It's a high energy physics. So there's a reason why we have a site at CERN. And there's both the big projects at CERN, Atlas and CMS, they both have people that are using Fabric. They're investigating new ways, mostly to manage large amounts of data flowing between CMS, Atlas, and computing centers, primarily in the US. Notably, so Frank Werthwein from UCSD/NRP/San Diego Supercomputing Center has used Fabric to do 400 gigabit per second experiments between Fabric and NRP. So this is a facility port connecting an external facility. And he's done this where he's moving data around at 400 gigabits per second across wide area in a simulation of moving things from CERN. And a result of this is that we've actually just worked to stand up 400 gigabit per second connectivity from CERN to New York. So now Frank can actually do 400 gig experiments from CERN all the way to San Diego, and he's working on his team is working on making that happen. So we're pretty excited about that. And that's an example of using a huge amount of bandwidth, which is cool, but it's not really totally the purpose. So the Atlas example is a different type of example. So they're using something called named data networking, and what named data networking is, if you don't know, is a way you can manage data where you don't use IP addresses at all. Instead, you label the blocks of data with addresses, so that data is addressed, not the locations. And then the the routers, if you will, that are in the system don't care about where like when you ask them to route to something, they're routing to data, they're not routing to a location. And this is something you can't really do natively on the internet, because the internet uses internet protocol, so IP. And they can actually deploy NDN like natively across Fabric and move things between CERN, and they move it to University of Michigan is what they mostly do. And yeah, and they call this Service X, and it's a thing they've been working on. It's pretty interesting. Also, a lot of educational use cases. So we had some data from last year, so fall of 23 and spring 24. We had 22 different projects using Fabric for educational purposes. A little over 500 students last year. a whole list of universities that used Fabric to do computer networking courses. Something to note about computer networking courses, if you're familiar with the Genie testbed that's been shut down a few years ago, we have ported all of the Genie educational modules to use Fabric. So some of these classrooms use the Genie modules in the classroom. But really notably at NYU, there's a professor named Freda Fund. She has a really excellent set of like teaching modules. Really, really, really well done. If you're interested in teaching computer networking with Fabric, you should look up Freda Fund or ask us. We can point you to her. She's really good. And then we have a really advanced user, Nick Sultana he's a professor at Illinois Institute of Technology, and he's done a classroom on trustworthy machine learning using RFPGAs. And that's a really successful class. He's got a bunch of students that have graduated and moved on to do really great things. And I think he just recently told us that he published a paper at SIGSI on this class. So if you're into education, there'll be a paper where Nick published this recently. Oh, and finally, there's a cosmology application. So we have a CMBS4. This is an astronomy application. So this is ideally they'd want to have Fabric connected to a telescope on top of a mountain in Chile. And there's some work towards that. But what they were able to do is at Florida International University, which is in the actual path they would take, they created a synthetic telescope, and now they can use that synthetic telescope to practice moving data back and forth between different supercomputers across the US. And they have some really interesting, like a shell they deployed on top of our FabLab library to do all of this. And they really took well to a lot of our APIs and like it. And they tell everyone how good our APIs are and stuff like that. So they're a pretty good use case. A little bit about the community. So we have a little over 1,800 users at this time, about 300 active users every month.
Hi.
Sorry.
No, that's all right, Tom.
Yeah, there's
That's right.
Or I just need direction. I have my laptop, my Mac laptop, it's 1 year old, and it appears two USB-C ports don't take power anymore.
Oh.
And at first,
I think, there we go. Yeah, so we have about 100 international users, getting close to 200 distinct organizations, a little more than 100 .edu organizations, a little over 200 projects. About 60 projects are active any particular month. So if you want to become a user, create a project, and we can get you there. Little background about how to use Fabric for the first time. So we have a few different ways to access it. There's like the main way is our portal. So portal is where you manage your projects and accounts. You can use that to deploy kind of small topologies. I'll walk you through that a little bit. It's also where we have our knowledge base and our documentation. So you can land there. And that's basically the jumping off point where you'll start. We have a Jupyter Hub. If you're familiar with Jupyter notebooks, we have a packaged environment for you to run Jupyter notebooks. It's really slick and includes all your tokens and permissions and libraries and all sorts of stuff. It's a good way to both run experiments, but also package them. And we have just our library. It's a Python library called FabLib that you can install anywhere you want and use Fabric from your laptop or your desktop. It requires tokens and management of SSH keys. So it's not really recommended for brand new users, but once you get familiar, it's kind of probably the way you'll go eventually. Fabric accounts, I kind of mentioned the top of it on the way to create an account that we use identity providers. So we don't actually have like an account for you. Like your account is actually authorized from typically your institution, your university. Everything's tied to it. Like I said, we do allow Google accounts, Microsoft accounts, and a few others like that. We prefer you to use your institutional accounts. And if you do use your institutional account, it'll be automatically approved. If you use one of the other ones, there's a manual step where we have to just make sure you're actually who you claim to be before we approve it. Enrollment, you go to the portal, you click the sign up link. Hopefully a lot of you have already done that. And Kamal has added you to the projects and such, so you can do some of the hands-on part in a minute. So yeah. Projects. So this is a thing, like if you're not used to these kind of experimental test beds, a project is sort of a group of experimenters that kind of work on the same thing. Sometimes it's like an actual project they're building. Sometimes it's like a professor who has a lab and they have one project shared by all the grad students. Sometimes it's a class where the people in the project are students taking a course. When you create a project, so you have this project. In order to create a project, you have to be a project lead. We generally reserve the right to be a project lead to being like professors or research scientists of some sort. Pretty much the only rule that you can't be a project lead is if you're a student. So if you are a student, you need to go be friends with a professor who will then become a project lead, create a project, and add you to it. The reason for this is that the project leads are responsible for the conduct of the members of the project, and we just can't trust students to do that. And the project leads need to be familiar with the acceptable use policy, and make sure that their project members follow it as well. Permissions. So generally, when you create a project, you have like very few permissions to use Fabric. You can use just some of the basic things. There's a bunch of more complex tools and components and things you can access. When you start using Fabric with a particular project, you might start seeing errors that say, "Oh, you're not allowed to use GPUs" or something like that. And then what you just need to do is have your project lead ask for the permission to use GPUs. If it's a scarce resource like GPUs or something that like our extended layer 3 service that peers with the internet, and is kind of a big security vulnerability to us. If it's something like that, say scarce or provides security problems for us, we'll probably get you to justify why you need that, and like we'll work with you to try to figure out another way if possible. Experiments, you can deploy experiments using, we have just a raw REST API. I don't recommend using that. I should probably use the FabLib library that wraps the REST API. It makes it a lot easier for you to run your experiments. These APIs use API tokens. They are short-lived. They last about 4 hours, but they can be refreshed. So you start using Fabric, eventually you'll run into an issue where it says your token's not valid. Usually it means it's expired. And then you just have to create a new one, log out back in, or just go get a new one from the portal, that kind of thing. Jupyter Hub is highly recommended for new users. When you start it, it comes pre-installed with all the libraries you need and the correct token for yourself. And you can package your experiments in these Jupyter notebooks. If you're not familiar with them, you should try to learn about them. They're really great. You can build topologies, configure it, run the experiment, pull down the data, make the graphs. You can do it all in one big notebook. Yeah, so you should do that. Session tokens, I kind of mentioned it, like there's a place on the portal where you can get a token. This is only necessary if you're running the libraries on your laptop or a desktop. If you're using our Jupyter Hub, it'll just automatically happen. But just know there's a place on the portal where you can go get tokens. And there's a bunch of information about how to use them. I wouldn't suggest doing that right away. Try to be used to things before you try doing that. Accessing experiments, something we have. I've worked on a lot of test beds over the years, and they get hacked all the time. Most of the time they get hacked because some user created a database with a default password and it was serving the internet. So we don't do that. We don't let that happen. The way your experiment looks, and I'll go into some more in just a minute, is that your VMs will have access to a management network that's connected to the internet, but it will only accept connections from our Bastion host. So if you want to access your VM, you have to jump through our Bastion host. So we have in the portal a ways to create keys for the Bastion host and keys for the VMs and push them all in the right places. Luckily for you, if you use our Jupyter Hub again, all of this is taken care of and you can kind of get started without having to know how any of this works. But if you start doing things off of the Jupyter Hub, you'll have to learn how our Bastion host works and what the limitations are. Getting help, we have our Fabric knowledge base. So this is just a bunch of documentation with a bunch of like gory detail about how to use our APIs, but also like articles that say how to get started or how to manage projects, that kind of thing. So I'll kind of walk you through that a little bit. We have a community forum, so it's a forum where you should subscribe. So if you're interested in using Fabric, I'll show you how to get to it. You should go to the forum, subscribe to our announcements, subscribe to the user community part of the forum, and you'll see a bunch of people asking questions about how to do all sorts of things. There are Fabric staff that are there to answer those questions, but also we see a lot of times other users are answering questions, and sometimes they're answering questions in ways where we don't even know how to do it. So we're glad the users are there. If you are an advanced user, go there and answer some questions for us. We want that to form the community. Some things need specialized support, and you don't really want to ask on the portal. Things having to do with like account issues and passwords and all these kind of stuff. So there's generally a way to create a ticket that'll come directly to some Fabric staff member. Usually if you're in the portal and you're on the section of the portal that's talking about that particular topic, there'll be a button there that says, click here if you want to be a project lead, and it'll create this ticket, or click here if you're having account issues and it'll create a ticket. So you can look for that. Okay, Fabric networking. I kind of alluded to how the Bastion host works. So I'm just going to go through this because this is something that a lot of people don't get right away. And I got like about 14 minutes to the top of the hour, so I'm right on schedule, I think. So we have a difference between like when you create slices on Fabric. The key thing is to know that you're doing something experimental in the network. But you also need to access your experiment. So typically when you do this in your own lab, you probably have your experimental data plane, and then you have some backdoor to get into it, and you kind of understand what that is. On Fabric, it's no different, right? So when you deploy a virtual machine on Fabric on some site, it will come connected to a management network that was connected to the internet. And like I mentioned before, you can't actually directly use this. You have to bounce through the Bastion host, but we'll get to that in a minute. Things to know, the IP addresses on the public internet is sometimes they're IPv6 and sometimes they're IPv4, but I'll get to it in a minute. The Bastion host actually solves this problem. Like you don't actually have to worry about that because the Bastion host knows both sides, so you can get in regardless of if your machine is on IPv6 or v4. This connection is intended primarily for management using SSH and like configuring the hosts. And as such, it blocks internet-facing services. So this is really your backdoor to get in so you can manage your stuff. The data plane, once you add a data plane to the slice, the experiment, you'll see that in this case, I have like 4 VMs. There's across 2 different sites. You have all the VMs have access to the management network, but they also have this data plane network that is completely separate and isolated from the management network. So the idea here is that you access your VMs from the management network, but your data plane is where you do the experiment. That's the key. And we're kind of, the way I've said it, we're kind of a cloud, but we also provide these like advanced network services. So that's kind of the terminology we use. So you can create a VM or a node. There's an entity that has computes, and it has these advanced PCI devices. But on the data plane, you're going to be deploying things that we call network services. And there's a few different types of network services, and I'll go over like the main ones for you in a minute here. So like I say, there's a Bastion host. You have to jump to the Bastion host. This is basically to prevent attackers from getting in. And this seems like it's difficult, it makes it more difficult for you, but I'm here to tell you that it probably makes it easier because now your data plane is completely isolated from the internet, and you can kind of do whatever you want, be really disruptive. You don't really have to worry about security that much because we've kind of isolated you in a sandbox. So a lot of people have actually said this helps them more quickly iterate on their experiments because they can kind of be a little loose with some of the security rules because we're blocking things out. So just know that that's kind of the security stance that we're taking. Okay, so data plane network services. This is a list, not a complete list, but this is a list of some of the primary ones. The network services come in 2 main flavors. There's layer 2 services. So this is like Ethernet level services. And then there's level 3 services. This is like IP or internet level services. So Ethernet level services are layer 2 services. We have L2 bridges, which this is basically like just having a local switch that you can connect machines to. There's an L2 point-to-point is what we call it. And this is a direct wide area connection. So if you have two machines that are on the opposite side of the world and they each have a NIC, you can plug them together with a wire that we deploy for you. And we call that an L2 point-to-point network service. We have one called an L2 site-to-site service, or STS. This is the same thing as the wide area, but there's two pieces of the switch spread out across the wide area. So it's almost like two switches connected across the wide area, and you can connect multiple machines to either end. Facility ports, which are layer 2 things, layer 2 services that are used to connect a port inside of Fabric to something that's outside of Fabric that we don't control. A lot of times that's something in your lab or another test bed. Layer 3 services, so these are like Fabric. We have our own sort of internet that we run. We in fact have two of them. We have one that's FabNet v4, so this is an IPv4 based internet that spans all of our sites. And we have an IPv6 based one we call FabNet v6. And you can, if you don't really care about that much happening in the core, you're more working on a distributed application that is going to do some computation in key locations across Fabric. You might just want to use FabNet v4 or v6, and you kind of don't have to worry about the low-level network. It's more aimed at applications. And it's also good for you to, if you want to deploy a control plane across your application, you can use this. We also have a FabNet v4 extended and FabNet v6 extended version. These are actually our internet, but paired with the public internet. And we allow this in some cases, but we try to be really strict because this does actually open up a pretty big security vulnerability to us. So if you need this, you can ask for it, but we'll probably try to help you find another way to solve your problem. And we have a couple of new services that are pretty cool. This one is called explicit route object or options. And this is an L2 point-to-point link, but you get to choose the path, and I'll show you a picture of that. And cool, it's pretty amazing. And we have port mirroring, which if you've ever done port mirroring on a regular switch, this is basically the same thing. And I'll go over that in just a second. So L2 bridge, what does that look like? Looks like this. So it's within one site, you can create a switch basically, and you can hook up as many VMs as you want to it. Keep in mind, it's just an L2 bridge, so it's just Ethernet. Any IP level stuff that you want to add to it is up to you. You have complete control over that. Phablib does have some tools for automating some things, but you're free to do whatever you want at any layer higher than Ethernet. And that's the key for it. L2 point-to-point looks something like this. You have two sites, two VMs connected across a wide area. The same thing, all we give you is the Ethernet connection. If you want to do anything at a higher level, like you want it to have IP addresses, you have to do it yourself. But we also have some tools that will help you do that if you want to use those. Interesting thing about this one is that this creates a path across our topology or our resources. And one of the questions it has to do is like, what path does this circuit take? And it's a little bit of foreshadowing to to the explicit route options, and I'll show you something. Because right now, if you get just the L2 point-to-point, you don't get to choose the actual path. L2 site-to-site, kind of like point-to-point, except you can connect as many VMs as you want to either end of it. Again, you don't choose the path, but you'll never be able to choose the path because it's just some low-level technical reasons. L2 site-to-site is on exactly 2 sites. So some people want to do this on 3 sites. You can't do that. It doesn't work. The technical reasons why you can't do it. And this is the same thing where we give you the layer 2 and layer 3 is completely up to you. You have full control over it. Do whatever you want with it. But the downside is that you have to do something to make the L3 work. The FabNets, the v4 and v6 looks something like this. So what these are is kind of interesting. These are, you give basically an L2 bridge, but we also deploy a router for you. And then we issue you a subnet and a gateway IP for that router. And this is not unlike what your ISP at home is doing when you sign up for service. There's a router and a gateway that they give you, and they give you usually one IP address, but sometimes more. And then you can connect your home network to the internet, right? And then the internet is up to your ISP and the rest of the internet to like forward traffic for you. In this case, we can create routers on various sites for you, and then we will take care of handling the L3 forwarding for you using just regular routers. So this is convenient if you don't actually care about how the traffic gets there. You just want it to get there in an easy way. A couple things to note here is that in this case, this is actually two separate network services. So when you go experiment with it, this is two network services, the other ones are each one network service. And then also keep in mind that your management network here connects you to the internet, and then this connects you to like the FabNet internet, and you have to make sure those IP addresses are disjoint, and you have to set the routes in the VMs such that you don't cut yourself off from the public internet, because then you can't get back in. And it's a pretty common thing people do. So you just have to make sure you have full control to do whatever you want, but you can also hang yourself. So be careful. And then, like I said, we have FabWV4 which we can take your routers and let you route from your VMs to the public internet. But that opens a security hole, so we try to make sure that people really need that service before we let that happen. Facility boards, this is the slide I showed before. It's the same thing, but you have your VMs wherever they are, and then you can connect to Chameleon or Cloud Lab or Amazon or your institution with a layer 2 circuit directly. There's not much for me to say like what's happening there, because I don't know what is in your facility and what you're going to do with it. You have to like be the expert that knows what's happening there in order to configure it, because it can be absolutely anything. We don't have any restrictions. The ERO service, this is like the point-to-point links, but it has exactly two endpoints. Instead of not knowing where it goes through our map, you get to explicitly choose the hops that it takes. And if you want to be kind of clever, you can make it take some sort of wily path, and you can control sort of the latency or the bandwidth. Maybe have two different links that have different paths with different latencies and bandwidth, and do some tests to see which one's better, or for whatever reason. So that's what this service does. Kind of an advanced service, and you probably won't use it anytime soon, but know it's there. Port mirroring, this looks a lot like port mirroring if you've ever seen it before. If you have two VMs connected to a network service, they're passing traffic back and forth. What you can do is take a third VM that's a listener, and you can mirror a copy of all the traffic to that listener. And this way you can use a bunch of tools to watch what's happening on your network, but you're doing it out of band. So like your two primary VMs get the same performance as they would otherwise, but you have a third listener that can see what's happening without interfering with the experiment. So that's a service that's available as well. There's also, as some people might know, we have a infrastructure level port mirroring service, and this lets you look at it's a little different, because it lets you, instead of looking at your slice, which this does, it lets you look at the things that Fabric is doing at the lowest level. And we have some people that are kind of studying Fabric and Fabric's users. And that's a slightly different thing, but it works kind of similar and has similar words, so don't get confused. All right, and I have 2 minutes. I got just under the hour, which is exactly where I was trying to hit. The next step is the tutorial. So kind of like 14 people, that's a reasonable number, and that also is a reasonable number we can actually like answer questions probably. Let me ask, did people get their accounts created? Maybe Kamal can say if she's on there.
I see 4 or 5 people filled up the Google form, but only few have logged into the portal. So after the sign up, if you can please log in once to the portal, it'll help me add you to the project.
So exactly what Kamal said. If you've signed up for an account, she's approved you, maybe you use Gmail or not. But if you log in once, she can add you to the project, and then you'll have access to all the resources, but before then you won't. So log in once and she'll add you. All right, so I'm going to, this is where I said I was going to do a thing where I have to stop share and then reshare so that I can get my screen set up so I can do my examples here. Let me see. And then I want to, where I lost my, I lost. I can come back here and I can do Okay. So I'm gonna reshare this one. Oh, not that one. Oh, this one. Share. Okay, cool. So you are seeing my slides. I'm going to scroll back down to tutorial here. And what I'm going to do here is the next slide here is going to show you how to run the experiment, but I'm going to jump over and I'm going to go to the Fabric portal and give you a little walkthrough of how the Fabric portal works. And then we'll go to running Jupyter Hub and doing examples. So I'm going to hit reload. So it said there was 1,804 users a little bit ago. So now there's, maybe people did it. Maybe people already had accounts. No. So this is the Fabric portal. You land here, you see just some information about how to, like what the portal is. If you wait, or this will scroll around and you'll see a bunch of information about different users that are doing different things. These are webinars that we do monthly. So if you're interested in learning more about Fabric, there's a tips and tricks webinar done by usually one of the Fabric staff members. And then there's usually a user-led webinar that talks about like what users are doing. All of them are on YouTube. So if you want to look at the old ones, they're on YouTube and you can feel free to do it. These are some of the recent ones. We also have our knit workshop, which we had last week, so you probably can't come to that. But we have them twice a year. So the next one is in mid-March. I think March 14th, I think, is the week. And it'll be in Raleigh. So if you're interested in using Fabric and you start using it and you want to like interact with the community, you can come to that. It's usually a few days. We also typically have money to pay for especially new users to come join the community. So if you're interested, there's travel grants available. So look into that. You land on our page, you can kind of see some stats. So we have 1,800 users or so, 200 projects, a bunch of 33 publications, even though we've only been open for a year officially, which is great. You can look and we also it's hard to get people to tell us about their publications, so we probably have many more than that. These are just the ones we found. And the slices, so slice is an experiment. So we've run 29,000 experiments since like in the last year, really, when we started keeping track here. So if you go here on the portal, I'm going to log out to show you what it looks like when you log out. And when you log in, it will ask you to log in with your institutional identity, which you might have done already. Mine is UNC Chapel Hill. So if I log in, it's not asking me to log in because I do my password because I've already done it. But now I'm logged in as my UNC persona. If you go to resources, you can see a list of all the resources that are available, how many of them are being used at any given time, how many are available of all the different types. If you're looking for a specific type of resource, you can come down here in this table and you can kind of look for, if you want a GPU, you can. So I guess people are asking questions. I assume that somebody will answer them, Charles or Kamal maybe. So if you want something that has a GPU, you can kind of like look and sort by it and find one. So there's a Starlight, there's 10 GPUs left. So you can use that. And so if you're looking for a specific type of resources, you can find them here. Also, and I won't go into this a lot because Charles is going to talk about this in a bit, but if you go to measuring and monitoring tools, we have all sorts of data you can get from our system, but I'll leave that for Charles because he's going to go deep dive into it. If you go to experiments, this shows you all the different projects you're a member of. So I actually create some of the ones for the teaching examples. So I'm a member of a lot of projects. You should be a member of one. So if you log into the portal and you click experiments and go to projects and under my projects, hopefully you see the Fabric tutorials project there, because that means you now have access to the testbed and you can use the Fabric tutorials project. And I'll do some examples here in a minute and you'll be able to follow along. Slices show you all the different slices that you have currently running. So I can, click on a couple and show you, this is an iPerf example, and you can kind of interact with it, and it shows you kind of what I'm doing here. And you can see my example, which I probably need to shut down, but that's okay. And if you go back to experiments, you sort of tokens, this is where you can manage your tokens. And like I pointed out before, you can create a token for a specific project and download it and then use it on your laptop. Once you get to the advanced stage and you're running things on your laptop, you'll need to come here. But as long as you're using our Jupyter Hub, you'll never need to look at this. When you do need to look at this, you can look up here. There's a guide that'll walk you through all how to do it. So come here and read that guide, and then you'll understand how to create tokens. SSH keys, again, this is a place you can manage your keys that go into your VMs, as well as the bastion keys that'll help you get through your bastion host. Again, like I say, when you use our Jupyter Hub, you don't need to do anything with this. It'll be automatically done for you. But when you start using it Fabric remotely, you'll have to do things to manage your keys. And Artifact Manager is something really new and really excited about. Kamal actually did a lot of work building this, and Michael Steely, who's not on here. So this is a way for you to package your experiments. So what we have here is a bunch of packaged experiments. There's 50 something or 52 of them. Many of these are our example notebooks that you can use to learn from, but they're also from users who have put them up. So this is from Ellie Kofi from the University of South Carolina, who does a lot of the P4 educational use cases that we have. And he has packaged up this P4 DPDK experiment here. And if you wanted to, you could just go download it, and then you could install it into your Jupyter Hub, and then just run Ellie's experiment via Jupyter Notebook. So it's a pretty slick way to do this. We encourage you to package your experiments, put them here, share them with everyone else. And eventually we'll have ways to put things here, but you can cite your experiment in your papers that you write. And that way we have these reproducibility efforts. You can have a place where your experiment lives, and different conferences and journals, whatever that want your experiments to be reproducible. People can just go to Fabric, download your experiment, and rerun it and reproduce it. So that's what this is for. You go here, so the knowledge base. So knowledge base is basically our documentation. There's a few different parts here. So there's something you guys might want to look at later after this tutorial is the getting started documentation. Has a bunch of information for how to use Fabric for the first time, joining projects, creating projects, managing SSH keys, getting help, all of the things. So like getting started information is all here. Each one of these is just a walkthrough of how to do a particular thing. This shows you how to create an account. Technical guides, this is also really important. One of the main things I always use here is if you go to this FabLib one, you go to the FabLib API, and this is just the gory details of how to use FabLib. You can click on here and you can find every function on our Python library, and like what they all do and how to use them. And it's a lot of details here. So this is you'll use this a lot if you start using our Python libraries. Jupyter Hub I'll skip for now because I'll go more deep in depth with that. Contact us. This is where you can go if you have issues that need to create tickets rather than the forum. Like I've got some private information or something you don't want to share. We have space for you to create you can click here and you can create a ticket that'll go to someone. If you want to teach on Fabric, you can tell us about your class. So this is a way we can kind of manage like how classes are using Fabric. There's also an educator forum. Oh, I forgot to tell you about the forum. I'll tell you that in a minute. And we have something called office hours. So you can just sign up. A bunch of the Fabric staff have like a few blocks of times per week. They're available, and you can go through this service here, and you can book a half hour or an hour with somebody so they can just talk to you over Zoom about whatever issue you're having. I do want to go back to this because I did forget. Once you go to the knowledge base, there's this go to forums button here. Go to the forums. This is where we're trying to build a community, so all of you should join the forum here. If you go to Fabric announcements, you have to log in to post. So if you log in using your regular identity, you can subscribe or unsubscribe to this particular forum, and this is where we announce things like, you can see a lot of them are, Los Angeles had a hardware problem a week ago, and so did Utah, and various other things like power outage in Tokyo, all sorts of other things that we're announcing, outages or either new capabilities or outages. So you definitely want to subscribe to that forum. But then the other one you want to subscribe to is this one called General Questions. So this is where users ask lots of questions and other users answer them, and sometimes Fabric staff answer them. You can see it's pretty active. So like somebody asked a question 3 hours ago and a couple of them yesterday. So it's pretty active. People getting all sorts of different problems or questions, and lots of users answer the questions and Fabric staff answer them. So definitely log into the list, subscribe to them. You'll get emails that say when new posts are made. Okay. And then if I go back to the portal, okay, a few other things we have about is about us, some pictures and stuff. There's the community, so there's news. You can read news about us. Knit is our workshop. So if you want to know about our next workshop, you can come here, different events, sign up for the newsletter, other test beds, how to cite us. There's blogs. So if you do something really cool, we're probably gonna ask you to write a blog about it. And if you write a paper, we want to know about your publications. So these are things about our community. If you want to go read about what other people are doing, you can go read the papers. That would be a pretty good start. All right, and then finally, we're gonna go to the Jupyter Hub. So I'm gonna go to Jupyter Hub. This is our Jupyter Hub. It runs in a Kubernetes cluster in Google Cloud. And we have a few different versions of the software, mostly because educators like to have a stable version throughout the entire semester, whereas the researchers always want the latest, greatest things and have all the bugs fixed. So we have a few different versions for you to choice. For today, if you're going to work on this today, choose the Beyond Bleeding Edge, which is the latest one, because we had a few updates we pushed to the examples for you today. So I'm going to hit go. It's going to ask me to log in with my regular identity. And this might take a minute to load, depending on how many of you try to do it at the same time. While that's loading, I'm going to go back to my presentation, and I'm going to show you what you're supposed to do here. So to run, and you should be able to see this in the PowerPoint as well. So the steps here, as you go to the portal, which is where I was, if you go to the user profile, which is where I was here, if I go to experiments, you should be able to see Fabric tutorial in here. If I search for it, tutorial, or search for it, you can see Fabric tutorial project. If I click on that, you can see a description of the project. You can see like all the permissions it has. You can even go see who's a member of it and various other things. This is how you manage your project. As long as you see yourself in the Fabric project, the Fabric tutorial project, then you are a member and you should be able to access it and run these examples I'm about to walk through. If you're not, then you need to like create an account and make that all happen. Kamal will help you in the background. Okay, so here is my Jupyter Hub. Is everyone that wants to do this, are you at this point? Is anybody frantically trying to do it and want me to slow down? I'm gonna drink water first. I guess you could say it in the chat would be a good place. Everybody's happy with me going as fast as I'm going. Okay. I'm going to slow down if you want me to slow down. Okay. So inside of this Jupyter Hub, what you'll see is a bunch of folders already pre-populated for you. What we're going to ask you to do is go to this one that says Jupyter Examples main. So Jeff, you might try, so I see the question is, I see the tutorial project, but when I try to access Jupyter Hub, it says I don't have access. If Kamal can, actually, let me see, I can confirm. Yeah, I was gonna say you might have to log back in, out and back in, because some of the stuff is it's stored in the token that you get. So try that and see if that works. If it doesn't work, then we'll get you going. All right. So once you're in the Jupyter Hub, you'll see a bunch of folders here. The one that you should look at here is this one called Jupyter Examples Main. So you might also see once the Jupyter Examples release and then a number. So the one with the release is actually released versions of our Jupyter examples, and the main is just pulling straight from our GitHub of examples. So go into the main one because we updated one of these yesterday. So if you go to the main one, you'll have the current one and it'll work. So once you're in here, what you'll see is a bunch of notebooks. This one here called Start Here, it's exactly what its name says to do. If you click on that, you'll open up basically an index of a bunch of examples that we have out there. And like I said, a lot of these examples are in our artifact manager as well. I think all of them are. And we're moving towards using the artifact manager instead of this Jupyter examples GitHub repo that comes pre-installed, but we're sort of in transition on that. So that just to quickly scroll through, you can see there's just a lot of examples. They do all sorts of things, and we'll kind of go over some highlights, but then I'm going to run a couple specific ones for you or with you. So the first section here is called Getting Started. The two main ones that we're going to have you run is this one called Configure Environment, and I'll get to that in a minute. And that'll actually set up your environment to use the tutorial project. You can also use it to configure your environment to use one of your other projects if you have another project or when you have another project. And then we'll do this Hello Fabric one, which basically what it says is basically just proves that your project, your environment is set up to work. If this works, then your environment is configured correctly, and we can move on to something more interesting. I'll just kind of quickly breeze through a few of these other ones. There's some new ones about artifact manager. This is about how to create artifacts or pull the artifacts. We're not going to do that now yet, but pretty soon we'll use those instead of these example notebooks. We have some basic examples here in this section. These are just basic things like finding resources, listing resources, submitting a slice, deleting a slice, listing all the slices you have up, saving a slice, adding keys, sharing a slice, modifying a slice, these kinds of things, some sort of basic managing of slices, customizing compute nodes, SSH tunnels. A lot of people like to use SSH tunnels to create a connection, a tunnel through our Bastion host. It's pretty useful. With storage, there's ways to use your local disk, ways to use the NVMe drives, ways to use the persistent storage. So this is the 250 terabytes per site that you can access. We can create a volume for you that lives like beyond just the life of your slice. There's how to use GPUs, and a bunch of networking ones, of course. So there's different examples for the different IPv4 layers, IPv6 layer 3, layer 2 things, facility ports, port mirroring, sub interfaces. And then for each one of these, there's a few different options for how to configure them. You can all the way from completely manual, all we do is turn on the basics, and you have to configure everything all the way up to like, it should just work with one click. And depending on your experiment, you might want one or more of those. So you probably want to run them all and see what they do and can become familiar, and then you can figure out how to do more complicated things. We have some experiment configurations. So we have like how to get keys into your slices, how to configure your slices in parallel to make it run faster, running post-boot tasks, which I'll show you a couple examples of in a bit, how to run Docker containers. So it's a pretty slick way to like deploy your experiments with Docker. And in fact, one of the experiments I'm going to show you uses this. We have complex recipes. So here's, if you want to deploy a router that uses OSPF or a switch using Open vSwitch, or you want to connect to, say, Chameleon over a facility port. We're going to actually run through this one eventually, this iPerf 3. So it'll actually make 2 VMs up on the other side of like Fabric, and then we'll do a test to see how much bandwidth you can get. There's some CPU pinning for performance. There's DPDK, SmartNICs. There's all sorts of storage. Exporting Grafana and Prometheus data. Measurement framework library examples. So that's something Charles also talks about a little bit. Kubernetes, Tailscale Mesh VPN. This one's pretty cool. Like if you want to access your VMs using your own private VPN instead of having to jump through the Bastion host, this is a highly recommended way to use it. It's some P4 labs. These are the laboratories that the University of South Carolina team put together. So if you do something really cool, we might actually add you to this list here. Oh yeah. So yeah, so a bunch of examples. It'll take weeks at least for you to go through them all and learn it all. So I'm just going to show you the very briefest taste of what you can do here. Okay, so the first thing that we're going to do, hopefully everyone's sort of caught up. If we go to this configure environment notebook, you can see that it opens up a notebook that has 4 cells. Hopefully everyone has seen Jupyter notebooks before, but if you haven't, they're pretty easy to get used to. So in this one, so this is a cell of code that you can run. This one is actually a bash, a Jupyter notebook that runs bash, actually this one is doing Python now. We updated it, I forgot. So what this does is it imports our FabLib library. So if you think of a Jupyter notebook, it's really like a running Python application. So, but you can run it kind of step by step and modify it in the middle. That's kind of how it works. And you can augment it with text that sort of communicates, documents what you're doing. So in this case, we're going to import our FabLib library. So this is our FabLib manager. Typically what you do is you're going to set the project ID to the project ID of your project. But because for this purpose of a tutorial, you're all using the Fabric Tutorials project, we've pre-populated this cell with the Fabric Tutorials project ID. So all you have to do is come in here and uncomment this line. Comment this one out if you want, but obviously the other one runs second, so it overwrites it anyway. And then if you come to the cell here, you can come up and hit this play button, and that sets that'll import the library and then set this variable to this project ID, and sets it to that project ID. It should run faster than this. Maybe I have to restart this notebook cell. Let me stop it and then restart this. Probably because I was playing with it earlier. Boom. Okay. So you can see it ran, and it now says it ran once. So we've done this cell. If we go down here, we can say show the configuration. So this is the configuration that this notebook is using. Sometimes if you have a problem and you're asking us in the forum or something, we might ask you to like send us the output of this, because that could show us some configuration errors that you might have in your system. So this is good to know, fablib.showconfig. This is actually going to generate bashing keys and slice keys for me and put them all in the right place, and configure my configure of some other configuration files inside of this Jupyter environment to use them. So this is the magic that makes it you don't have to know anything about any of the keys or the tokens or the anything. It just happens. So if you run this whole thing, hopefully you get to the end. It says configuration is valid and please save the config. And then I save the config and now I'm set. All right. So now my environment is set. For those with a keen eye, you can probably know that I could have just hit this double play button and it would just run through the whole thing and it probably would have just worked, but I wanted to show you how to run it step by step. So has everyone got this far? Anybody not got this far? I'll keep going, but then if somebody says they're behind, I'll slow down and we can help you. So the next thing we're going to do is we're going to go back here to the Start Here notebook. And I want you to go to the Hello Fabric notebook and open it up. So this is going to be your very first Fabric experiment called Hello Fabric. And it's not going to do a whole lot, but it's basically going to confirm that your environment's right. So I'm going to go ahead and run this because it does take a minute to run. But then I'll talk about what this is doing. So this is a bunch of text here that kind of tells you what you're doing, tells you that you should configure your environment first. This isn't going to work unless you configure your environment. You ask questions on the forum and so forth. Then the first cell that it did, and I already ran this, it imports our Fabric library and prints out the config just to make sure the config's sane again. Then it's going to come down here and it's listing all the sites. So this is actually going out to all the sites and like collecting all the information about it, about what resources are available, and it's going to print it. And it does sometimes take a minute if it hasn't been run in a while. So feel free to ask questions on the chat, because some of these steps that are about to come up, or you can just ask questions with your voice if you want, because I think we only have like 14 people, so it's not even that many. I lost my thing that says how many people are there. I don't know where it went. 16 people, it looks like. So if you want to, I mean, if you have a question, you can just unmute and ask, because these are going to, some of these steps are going to take a bit to run and involve some time. Also, I want to drink water. Everyone's just making progress. I feel like this should have gone already, but we'll see. It should work. So the way this is working, so this next thing is, like I said, it's printing a list of all the sites. I'm not sure why it should go faster than that, but it'll eventually get there. And then we can look at the cell that is actually going to create the slice. And this is the simplest slice you can possibly create. So you say here fablib.newSlice. So slice is a group of resources that are kind of working together to do one experiment. I'm just going to name that slice. I'm going to name it my slice because I'm not very creative. And I'm going to get a pointer, a reference to that object. Then I'm going to say slice.add a node. So I'm going to take my slice. I'm going to add a node. I'm going to call it node 1. I'm not going to have any other specification for like how big this VM is or where it is or anything. It's just going to give me the default, which will be the smallest VM allowable, and it'll give me it'll put it on a random site. Like I'm not even going to choose what site. And then I'm going to say, so this builds, so now the slice is a request, and now I'm going to say slice.submit. And when I submit it, it does this. So now what it's done is it's gone out and it says, I have this experiment on run. It needs one VM, nothing else, smallest VM possible. I don't care what site. And in this case, it looks like it went out and it found a spot for me on the Seattle site. So I'm going to be in Seattle. And it's ticketed. So I now have a ticket to run a VM on the Seattle site. And it's currently configuring that. And yellow generally means that it's in progress. It's doing something. It's not done yet, but it's not unhappy yet either. If anything turns red, then that means something failed. And if it turns green, that means we're done and it worked. And what will happen here is now this submit call is actually polling, and every about 20 seconds, it's polling again to figure out the state. And in about 200 seconds, it should have this VM up and running in Seattle, and it'll turn back control back to me. So we have about 120 seconds for someone to ask a question. And anyone can ask a question if they want, or I can just ramble. Is anyone trying this right now live? Yep, cool. Is anyone further along than I am? No? Yep, okay, you're already. Are you stuck? It looks like Anna says that she shook her head like, no. Are you stuck? Like something's broken? Somebody can help you with?
It's not broken. It's just doing the whole configuring and ticketed thing.
Okay. Oh, cool. So if you get past about 300 seconds, then we should probably think about like what went wrong. But typically about 200 seconds is what it takes. Some of the sites are faster than others. It really has to do with like we're dependent on the public internet, basic internet of wherever they are, like whatever university or whatever they're in. So some are busier than others, and this should happen. All right, I got plenty of time. Cool. Where are we? 162. I got about 40 more seconds. Maybe. And when this is done, it'll run, it'll show us more information, like how big the slice is, like which actual node it was on, and a few other things. Okay, so you can see my node became active, but the slice is not quite active yet because it's doing some last minute things. The next 20-second interval, it should all be active. Then the interesting thing here is like that actually is just deploying the slice, but there's a bunch of what we call post-boot configuration steps that can optionally happen, and that fablib is taken care of. So that's the library. So you might have seen that go past really fast. There's some post-boot config steps. They went really fast because this particular request didn't have anything complicated in it to do. So let me see here. Let me make this a little bit wider so I can have more things here. So now what you can see is that we have this node, it has 2 cores, 8 gigs of RAM, a 10 gig disk. It uses default Rocky 8 as its operating system. It happened to go to Seattle worker number 1. The username is Rocky, and the management IP is this, which if you don't know, that's an IPv6 address. So some of the sites are IPv4, some are IPv6. This one happened to be IPv6, and in a minute I'll show you why that doesn't actually matter to you very much. It shows you here, this is like the keys that were pushed into this particular VM, and this is a really cool thing we added a while, like in the early days. So this is actually the SSH command that you would use to SSH to this machine from your Jupyter container, or your Jupyter container. So what I'm going to do here is I'm going to hit plus here, and I'm going to get a terminal. And then I'm going to drag this terminal over here on the side. So now I have, and I'm going to make this smaller. So now I have, I have to go back to Hello Fabric. So now I have my notebook over here, and I just have like a terminal window over here. And in case you didn't see how I did that, I hit plus, and then in here is a bunch of choices, and then one of them is terminal, which is, will just give you a terminal window. And I'm going to, once that comes up, I'm going to drag it down here because I'm going to use it later. And we're going to have 2 terminals going at the same time. So what you can do here is if you come over here to this SSH command and you just copy it and paste it right here, you can SSH. And now I'm in node 1 in Seattle. And you can see here, if you have a keen eye with SSH, you can see I logged into the Bastion host, and then I logged into the node, right? So I'm actually hopping through the Bastion host here with this command. So you can see this command uses my slice key, which is the one that was created for me, but then it uses this custom SSH config file, which you can go look at if you want. And inside that SSH config file has a bunch of stuff that says jump through the Bastion host, and here's how to do it. So if you ever want to like do this from your laptop, go look at that SSH config file inside your container, and there's an example on how to do that, and you can just copy that over to your laptop. Then it's saying I'm going to use the username Rocky because these are cloud images. They all basically, the username you use is the same as the operating system that you use, and I'm going to do it to this particular IP address, which is the one that is the management plane. Okay, so my thing worked. I can say IP address list if I want. It's really boring. It has one interface. It's the management interface. And then I have my loopback, and that's it. This is not that cool of an experiment. But if you got this to work, then you are like, your stuff works. I will show you one last thing. If you go back to the notebook, and if you run the rest of the notebook, you can actually do some things like slice.show. This is just kind of showing off some really basic things that Fablib will do. Slice.show, list the nodes, will list all the nodes. If you have more than one node, it'll have more than one row here. And this last one will say slice.get nodes, and you can loop through them, and then you can say node.execute and pass in like a bash command. And in this case, the bash command is going to say hello fabric from node, and it's going to have the node tell us its host name, right? So if I run this, it's actually going to execute that command on the node in Seattle. And this is actually using the Fablib library, and it knows about all your keys, and it's using Paramika to SSH to the node via the Bastion host. So it's bouncing through the Bastion host to your node, running the command, and then returning the answer to you. So that's what that does. So that's kind of cool. And then and you can put any bash script you want in here. So this is like also how you can configure these machines. You can say sudo yum install some giant list of things, and then it'll do it. right? So now you can configure these nodes programmatically. So lastly, what I'm going to do is I'm going to come down here, and this one will delete my slice. So I'll just delete the slice, and now the slice is gone. And that's a good thing to do when you do that. All right, so I think everyone got that far. Everyone who wants to get that far, anybody got that far? So I'm going to go back over here, and I can tell you, like, you should spend time like just running like all of these. Like, have fun. It's like really kind of cool to like launch things in, you know, Switzerland and like play with them. So go ahead and play with all the different capabilities we have. Especially the networking ones are pretty interesting. Especially the different ways to automatically configure all of the nodes once they're up. But I'm going to go down here, and I invite you to do the same. And click on this one called iperf3. So a lot of you are probably familiar with what iperf3 is. So iperf3 is a tool that you can use to measure the bandwidth that you can get between across a network. So what this particular one is going to do is it has a bunch of examples of some cool ways to use Fabric. So step one, I opened it. I'm gonna right click up here. So some of this is me gonna be showing you some tricks I know about how to use Jupyter Hub. So if you right click the tab, this is iperf3, and you say show file in browser, it'll move the browser window over the side here to the folder that has this notebook. And I'm going to show you that because one of the things that we're going to do here, actually, let me run this because it does, again, take 300 seconds to run, right? So what we're going to do here, so you can see I imported the library. This is the top of like every one of these notebooks, is just import the Fabric Manager and show the configuration. The next thing I'm going to do, well, I probably shouldn't have done all of it. Actually, I'm going to do that. Stop, restart. I want to make sure I get a good set of nodes. So here, what I'm going to do, I'm importing the library. I'm going to name my slice iperf3. And here I'm going to get 2 random sites. So this is a way for me to, instead of saying like in the Hello Fabric, you remember we didn't even pick a site at all. We just submitted a site and it got a random one. But in this case, I actually want 2 random sites and I want them to be different. Like I don't want them to randomly land on the same place because that's boring, right? Because we're going to test bandwidth. So this is going to use the Fabric library to get random sites. You can also, there's notebooks that show how to say like get a random site that has at least 1 GPU of this type or something like that. There's ways to do that. So you can kind of code up a way to build your slice such that it will work on with the available resources currently. So that's something. So yeah, Georgia Tech and Atlanta, which is also boring because those are both in the same city. So I'm going to run this again. So like, and if I don't get a good one, I'm going to manually set them because I just want an interesting one. But Georgia Tech and Atlanta is pretty boring. It'll probably give me Utah and Salt Lake City because those are also both in the same city. But it does. If I don't have ones that I'm happy with, I'm just going to set them manually. I'll show you how to do that too. Yeah. Okay. And this does go out and pulls like all the information about all the sites to find it because it's way more powerful than just getting a couple random sites. It can be pretty sophisticated. I don't know. I'm just gonna set these because I want it to be interesting. So I'm gonna say site 1 equals, I'm gonna say CERN, and site 2. But site 1 is CERN. And this is an example of how to edit things live in Jupyter, which is kind of another thing to do. Let's say Starlight. So Starlight, so that's Switzerland and Chicago, right? And those are the 2 we're going to go with today. So I got Switzerland and Chicago, and then I'm going to run this real quick because it takes a little while. What this is going to do, it's going to create a new slice. It's going to name it iperf3. And then what I'm going to do is add a node, and I'm going to name the node node 1. I'm going to explicitly say it should have 4 cores and 16 gigs of RAM, and it should be at site 1, which I know is CERN, and it should use the default Rocky 9 image because that's the one I want to use for this. Then you can see it started building it. Then I'm going to say add FabNet. So this is actually like the tool that allows us to add a FabNet v4 network and have it automatically configure, and we don't even have to worry about it. So if you were to go back to, I go back to my start here notebooks. If you look at, let me scroll to the right place. If you go FabNet v4, layer 3, full automatic, this is the tool I'm using. You could do manual, but like there's just more steps, and I don't want to do more steps. But if you want to learn how to do all the steps, you can do it in that other notebook. Okay, so this adds the network, the FabNet network. Just for completeness, I will show you that looks something like this one right here. So we're going to end up with 2 nodes, one in CERN and one in Chicago, and they will be on a FabNet network, and they will be configured to use the router and talk over our FabNet L3 forwarding network. That's what's going to happen. So there's two of those, and they will be able to talk. Okay, so then what it's going to do is it's going to say node1.add post-boot upload directory node tools. So if you look here in this folder, library of 3 folders, there's a folder here called node tools. And what I've done is I've dropped in a couple little scripts here. They're just those bash scripts. One says enable Docker, and the other says host tune. And so that folder is going to be copied to the VM after it's booted. And then we're going to run host tune, which will actually tune the TCP and network a little bit to make it so that it gets so it can get high performance. And then I'm going to turn on Docker. I'm going to turn on Docker for this particular image, which is Docker Rocky 9. And then I'm going to tell Docker to pull this this Docker container that we have in our Fabric testbed that basically has, we call it multi-tool. So it just has a bunch of things installed in it, including iperf3. So I'm just going to install that, and then we're going to run it, and we're going to run iperf3. So all of these things happen in order after the node is booted, and FabLib takes care of that, which is kind of cool. Then I'm going to create another node. It's exactly the same, except it's at site 2, which is Chicago, and it's going to do the same thing. It's going to upload that same set of folder with my scripts, and then I'm going to have them run. So you can see here that it's starting to boot. For whatever reason, CERN is completely done and Starlight is not. We're about to 200 seconds, so it should hopefully get done soon. CERN and Starlight are actually 2 of our most popular sites, so if we get poor bandwidth, it's probably because there's a bunch of other people using it right now. CERN is actually sometimes completely full because the people that do high energy physics, they do things at scale. They use the whole machine usually. All right. And what we should see here after this has been submitted and things got created, there should be a post-boot config step that will actually take a significant amount of time, like 100 seconds or so, because if we look at this enable Docker script here, which we can look at and edit, basically if we go down to the part that says default Rocky 9, you can see that it actually just does a bunch of like DNF install of a bunch of things and configure the firewall and whatever, right? So this DNF install actually takes a non-trivial amount of time. Okay, ooh, so now everything's up. We have our nodes and our networks are up. The whole slice is still configuring a little bit. Probably the next time through it'll be done and it'll start running our post-boot config step. And our post-boot config step will start running all of these scripts, and that will also take a little bit of time. Any questions while we have another 100 seconds to wait? So far so good. Everyone's excited and being successful and thinks they want to use this forever for all their tools. All right, I'm not sure. So one of those things it does before it declares victory and that your whole slice is up, it tries to SSH to each one of the nodes and just confirms that it could SSH to each of the nodes. And so it won't give you back control until it knows that the machines are both up and like accessible. So sometimes when it's doing this, it takes a little extra time. It's because something's slow coming up and it's waiting for like the SSH daemons to turn on and things like that. But as soon as it says everything is active, It should be almost ready. Did you break it, Kamal? I feel like it should have already pulled again.
No, I think it's just on the boundary, right? 250.
Yeah.
So should be okay.
And also, like I said, people use CERN quite a bit. So there might be somebody doing something big at CERN right now. Or one of Dick Sultana's students. They do all sorts of crazy stuff all the time.
I think CERN and STAR both are always used heavily.
Yeah. Actually, probably should have used some other ones. I feel like it's been more than 20 seconds. Oh, okay, there it's going. Oh, weird. It just didn't refresh. This is just, yeah. So it actually did the post boot step, and node 2 is actually done doing its post boot step. So it's configured everything. So that's the Starlight one. Hopefully we'll see CERN in a minute. I got 14 minutes before I have to hand it over to Charles. So I think I'm all right. But I can't see, I don't know the IP addresses yet, so I can't log in yet. Yeah, I probably should have used, I probably shouldn't have used CERN. That was probably a bad idea. I just wanted to do an interesting one. Should have used Amsterdam. You can do it. Okay, there it goes. They're both done, saving. Okay, so now we have, everything's up, stable, okay. We have our 2 sites. We have more information here. So now you can see, I'll make this a little smaller so you can kind of see this. These 2 are our 2 nodes. You can see one is at CERN and one's at Starlight. They both have IPv6. We can SSH to them with these commands. We'll get to that in a minute. We also see that we have 2 networks. These are our layer 3 Fabnet v4 networks. One's at CERN, one's at Starlight. And you, like I said, you get issued a gateway and a subnet. So in this case, you got issued this subnet and this gateway, and this subnet and this gateway. And these are the ones you can use to configure your nodes. But since we used auto IP, it did it for us. So you can see down here, I think, yeah, you can. These are the different interfaces. So on our 2 nodes, we have 2 interfaces. The one at CERN got this IP address, which you can is obviously just the second IP address in that subnet, and then the one at Starlight got this address, which is the second IP address in the subnet. You can see the physical device names and various other things here. So what we can do now, which is kind of cool, I can close this to give us some more room. Actually, I need to move this over so I can close that. Can't I close it by hitting this? No, I hit this, yeah. Then I can copy this SSH command here, and then I can copy the other SSH command here. And now we have 2 terminals, one into node 1 and one into node 2. And what you can see if I do like IP address list here, you can see that we have extra information. So we have our loopback device, we have our ETH0, which is just the management interface, and we have ETH1 here. And ETH1 has this IP address, which we know is the one that was assigned. Which one is this? 21. This is this address right here that was given to the CERN. So node 1 is the CERN, the CERN node. It has this IP address on its data plane, right? Where it has this address on its management plane. And then we can see that subnet's there. We can see that we also installed Docker, so there's some Docker interfaces that are there. If I do IP route list, you can see that we have this particular route that was added that wasn't there before. So this is the subnet of all of FabNet v4. And then we're saying to go through this gateway, which is the gateway that we were issued here. So now any traffic I send to anything in 192.128.0.0/10 will go out the data plane. Everything else goes out the management plane. And now I can still access my VM, but I can also do things on the data plane. So if I wanted to, you can see here that the address on my Starlight node is this address. I should be able to say ping that, and I can see that it's working, and it's 115 millisecond round trip time, which seems to be about right for CERN from Switzerland to Chicago. So that's working, right? I can also do Docker PS, and you can see that Docker works. It's there. I can do Docker image list, and it should see the multi-tool that I had it install a bit ago, right? So it's there. And then what I can do is I can run Docker on either side. So if I wanted to, I could just let me run this like by hand, and then I can show you how to run it not by hand. I don't know, maybe this is a bad idea. So then I can run. And then, so this will actually run the Docker container, but it'll run iperf3 as a server, and it'll run it one time, and it'll run it on, I guess this is CERN, right? So I'm running that, and now it's running in the background. I should have maybe said don't run in the background. But here, now I'm going to say run it here. And then I'm going to take off the remove. Maybe I want the remove, don't I? Host network. And then I'm going to say here. And what this is going to do is it's going to run, if I have to do this. Oops. It's going to run in this Docker container. And I need to replace where I say node 1 address. I need to replace it with the CERN address, which is this one. So this is actually going to run a Docker container in Chicago that connects to the Docker container in CERN, then runs an iperf test for 30 seconds, and then tells me the result. So in theory, this should just work. So we have to wait 30 seconds, and we'll get our result back. I feel like if I typed it a different way, I can make it tell us the results while it's happening. But now I think we just have to wait 30 seconds. And I tuned it a little bit, but I didn't go all out. So we won't get the full 100 gigabits per second. Plus, someone is doing a lot of things on CERN, and I didn't get dedicated network connectivity anyway, just to kind of stay out of everyone's way. All right. Okay, so this is the result of our iperf test. You can see that it ran forward streams, and you can see down here that I got 33 gigabits per second between this little piddly VM in Chicago and this piddly VM in CERN without even much effort. I will also show you here, let me just make sure this went away. Docker PS. Okay, so deleted the VM, that's good. But what you can also do is like script this up to run from your Jupyter Hub. So if you did it here, you can see this cell that I have. If I just run it, it's going to do the same thing. So it's actually going to get node 1, and it's going to execute that command. It's going to tell it to be quiet and write an output to a certain log. So this is the log that is right here. So we'll see, actually, it's a show file in browser. We'll start seeing logs here, right? So it's actually logging to this log file, the output of this call to exec. And then this one is going to get this is node 1 that get the interface that's on this network, and then get the IP address of it. So this is like in code how to get this address. And then it's going to say, let's execute Docker run and run iperf, connect to that node, that IP address, and then do it for 4 threads for 30 seconds and so forth. And then you can see the output again. This time I got 34.7 gigabits per second. So this is, starting to be like a real experiment that you're doing. And of course you have to design your own experiment. And yeah, so here's that. I have the next thing. Okay, so this is, if you wanted to follow the directions, you could. And the next thing really is the measurement framework demo. So this is, I'll probably turn it over to Charles here in a minute. But maybe I'll let people ask questions if they have any for 5 more minutes. Everyone going to be quiet? Some people are running things, so I assume you're interested in actually using it. Yeah. Yeah. If there's no questions, then I'm going to turn it over to Charles. Are you there, Charles? Yeah. Yep. I will unshare. I will unshare and then let you share, so you can drive your own thing. I just have to figure out where my button is to unshare. Okay. All right, Charles, go for it.
Let me share my screen.
Yeah.
Okay, I put a link in the chat that will take you to the slides. And the slides will have some different links in there if you want to follow along with some. There are a couple of Jupyter notebooks that go along with this tutorial. 2 of them are really just kind of a recap of what I'm talking about. And then the third one is the API that you can use to actually grab the metrics. So I won't leave this up very long for the moment until we get to later. And I have just a few slides to start off with. Okay, so the fabric infrastructure consists of about 30 to 40 sites all across the US and the world. And they're all connected with high-speed links, some of them optical data. We have different sets of metrics that we are measuring, and we're making certain sets of these metrics available to the public. We have basically on each rack, well, each one of these sites is a location, often at a university, where we have a rack in the data center, and that rack usually consists of a head node and then several worker nodes. In general, usually have 3, some have more. There's also switches on there, there's some storage. Some of the racks have a GPS, PTP clock, which is a high resolution clock so that we can synchronize all the machines to high accuracy. We also have services running on the machines. We have OpenStack, Docker, Prometheus is gathering metrics for Grafana. Elk is also grabbing metrics and logs. We have the control framework and user services. So there's lots of components out there that we can measure. We're using Prometheus, which is based on open metrics, and it is the system that I'm going to talk about mainly today. It has a very simple method that you have a device running, where there's a head node and you have a process running that will look at statistics on how the head node is running, what the CPU load is, and things like that. Or you could even have just a single program running, and that program can write an exporter that will send out this data. So what we have a bunch of miniature servers out there running, and we have a central Prometheus instance, which will go and pull those servers for information, and they will return information in this format above. Basically, it's got a help, which tells you what the metric is about. It's got a type, which tells you what kind of metric is. When they're talking about metrics with the Prometheus, these are basically always numbers. So they're very easy to store and to measure. There's no logging or data like that. The information we get comes from the title in blue of the metric. In this case, it's the HTTP request total. And then the metric comes with a set of labels. In this case, we have a method. The HTTP call was a post, and it returned a 200 value. And then it will return the numeric value in this, oops. In this case, 1023 200 codes, and then it will give a timestamp saying exactly when that event happened. And the same thing for the code 400, but there's only 3 of those because hopefully your site works most of the time. So we gather those information with using Prometheus. We store it in a time series database, and then we use Grafana to visualize the metrics. We have a large set of metrics that are available. Overall, Fabric measures an immense amount of information. I'm going to kind of go from the bottom down here with the operations metrics. This is the information that is used by our operations team. It has immense detail. It has some private information and things like that that we don't want to get out. But we want to make the information available to the public. So what we've done is we've set up other levels of information that we're sending out. So these other ones, the public metrics, is a separate gathering system that takes information from the operations network metrics, and it puts it onto a server that just has the public metrics, and that is available to the public. That way, we're just releasing very basic information, things like the link status, whether links are up and down, how much information is going over links, and it's available to anyone, and that server just has that information. So there's no chance of if that server gets hacked, it doesn't matter because it's all public information anyway, so no private information is being leaked. In the same vein, we include more information in the yellow part with this we call the infrastructure metrics, and it's still non-private infrastructure information, mainly things like CPU disk loads, your standard Unix kind of measurements, and it's available to any Fabric user. So if you are a Fabric user and you're part of a project, you can authenticate with Fabric and log into that one. And then we have another one that is the research metrics, and it's got still basically non-regulated information, but it has a lot more information, and it requires a proposal for you to write to see whether or not we think that your proposal is a good use of that information. So very few people will be able to access that information. So we have several different types of data. The system level data is what we're looking at here mainly, the bandwidth, packet counts, CPU memory, disk usage, things like that. There's also a lower level optical data that is publicly available, and this is on the ESNet portal. I'll show you the link to that. I won't talk much about that because that is way beyond my understanding of the details of how optical systems work. But if you're interested in that, you can go to that link and see all sorts of information. So basically the infrastructure performance data, we have created several sites that you can access, and we've linked those in from the Fabric portal. And I'll go there in a minute and show you that. That way it's easy to find if you forget where it is. Okay, slide part is over, so let me go to the portal. This is the Fabric portal, which you've already seen with Paul's talk. In this, you can see that there's some data that you're being shown. There's 29,000 slices, there's active slices, total users, and publications. This is a different set of information that is being stored. I believe it's mainly with ELK. So you get a kind of overview of that information there. We don't give out the details of that, I don't think. Then we also have what resources are available. So if you go down to the map, you can hover over any one of these sites and look over to the right, and you can see what is available. It tells you how big the resource is, or how many the resource is, and how much is in use. You see Atlanta, it doesn't have any GPUs. It's got smart NICs and no one's used any of them. Then you also see the red slice there in maintenance. So the site information I'll be talking about in detail today is in the measuring and monitoring tools. And there are 3 links, I believe, and there are actually 4 links now. And I'll go to the public metrics. This is the very basic information that anybody can see, whether you're a member of Fabric or not. So we're using Grafana to display, make this available, information easily available. We've also added a front page, which will give you a bit more information. So when you go to the straight public metrics site, you'll present with this entry, and it has some basic links that tell you where to go and a little bit of information. And as we move forward, we'll be adding more of these links, and we'll be adding help pages in between these links. Here you can see there's the links to the Fabric ESNet. And there's also a one-way latency system, which I may show if we have time later, that uses the GPS PTP high resolution time to figure out what the latency of a packet moving from one rack to another is. But let's look at the link traffic graph. So if you remember that picture I showed just a minute ago with all the sites on it, all the yellow lines and the blue lines, these are all the sites that are on there. Just a big long list. And you can see that we have a lot of data. We have the information from every link that connects all the racks. And not every rack is connected to every other rack, but a lot of them are connected to more than one rack. If you scroll down here, you can see that it is a long list. So we can narrow that down. You hover over these, you can see what the site is. So this is FIU. It's got 44 gigabytes. Salt's at 38. Star.
Hey Charles, make it for 24 hours or for 2 days. Someone was doing something really big earlier this morning I ran into. Just interesting just to watch. You can kind of see the different uses, like how people are using it. Someone was doing like 100 gig stuff for like quite a bit of time earlier today. Yeah.
They're maxing it out then. Well,
yeah. Yeah.
So statistically, 100 gigs is the max you can get. And due to some timing issues of what your time frame that you're covering, you can actually get a little bit more than that. But you're really only getting 100 at the best. So where are these? This is all Star Washington. But as you can see, now that we changed the view and we have these 100 gig ones, the scale of the view will change. So now all this other information is tiny and you can't really tell what's going on there. And even here, you have a really hard time seeing what's going on. So one thing you can do is you can go over here. We said Salt was one that was fairly busy. And this is one kind of bug. Since we have so much information in here, the colors get a little bit confusing because they're so close together, and then I think it runs out of colors and starts repeating them. So really what you would want to do to narrow this information down, in this case, because we have so much of it, is to go over to the source rack. And a lot of dashboards in Grafana use this method. These are drop downs that control template variables or variables for the what you're actually sending for out in the queries. So this query is saying, give me anything from all these racks. But I'm going to say, just give me something from Atlanta as the source rack. And I'm going to leave the destination as is. So that means now that it will go and take all the sites that are connected to Atlanta and show you the information for that. And that pretty much fits on one page. So you can see, and you can see that there is a peak here in yellow at 48 gigs from Dallas to Atlanta. So if we wanted just to look at that, we can either go over here and see Dallas and Atlanta and kind of narrow it down that way. But we can also go to the destination rack and just go to Dallas. And now we just have basically the in and the out of Dallas switches. So Atlanta has a switch and Dallas has a switch. And the data from Atlanta has the data coming in, how many bytes are coming in from Dallas, and then how many bytes are going to Dallas. And the same thing at Dallas, it has how many bytes are coming from Atlanta and how many bytes are going in back to Atlanta. So if we want to see more detail, we can zoom in just by clicking on this and going in. And that gives us a much closer view. We can get isolate the data that we're interested in much better. I want to get zoomed into a certain amount, and you can see each data point. For most of the data we have, we are collecting at 30-second intervals. So going too much closer won't help you a whole lot. You can also pick the time of how often or how long we look at. In this case, the query is asking for everything that happened in the last 5 minutes. This is a relative time span. And as we run, it's got an auto refresh, and you can set that to 30 seconds. So every 30 seconds, this will automatically update, and you can sit there and watch as you run your experiment to see what's happening. For the relative time frames, you can do hours, you can do days. You can kind of pick pre-selected times, so the last 7 days, 30 days, 6 months, a year. You can also go over here and just pick whatever time span you want. If it's just 4 days, you can do that. You can also do the now minus 3 days. Give that information. If you want to, when you zoom in, you'll notice that it actually puts the exact time and date up here. So this is the absolute time. So if you have an experiment and you ran it from 2 o'clock to 3 o'clock, you can actually go and just look exactly what was happening when your experiment was running. And this is nice because you can do that after your experiments run. And the other nice thing is that you're able to save this and refer to it later, because we keep this data. Currently, we'll pretty much guarantee at least 3 months will be available. We're basically keeping the data forever, but as we get more and more data, it makes the query time longer, so it slows things down. So if you would need data for farther distance back, you'd have to request that. Basically, so we don't overload our systems. And as I mentioned, all this information that we've done, we've set these variables from Atlanta to Dallas, and we set the time span. And all that is encapsulated in the URL, so you can just copy that and share it. Or you can do this share and set a few more values, then just create the link. That's also good because if you have something that's happened weird and you want to show it to your instructor or something, you can just remember that and show it. We also have another type of graph. This is the current link status. The one that we just showed you shows a timeline and graph over time. This one basically just shows you what is happening right now. And we have a kind of a matrix form where you can see all the graphs, all the racks on the X and the Y axis, and then you can look at it and see what's happening. So from Atlanta to Dallas, there's 6.42 megabytes per second right now. And as the data gets higher usage, it changes colors. And we can do a similar thing here where if we reduce it to Atlanta, it'll make a much smaller, more compact graph. So now we can see everything that's Atlanta is connected to Atlanta and what the data rates are happening through those. We also have the links without any information, and we also have that in graph information. So what's happening with those is that's if a link is down, or if the reporting system that's trying to connect to that link isn't able to get the data, it'll be in that link, in that section. You can see that here in the node data. So again, the difference here, this view is the current what's happening view as opposed to a graph of the time. There's also different data that's coming through here. We have data plane in bits, out bits, and total bits. When I was showing the graph earlier, I showed you, Atlanta had the information from what was coming in from Dallas and what was going to Dallas. That is basically the in bits and the out bits. So the in bits are what's coming into the interface, the out bits is what are leaving the interface, and the data plane total bits are what's leaving and coming into the interface combined. Another type of graph that we have that allows you to reduce the information that you're seeing is the top or the bottom number of instances. In this case, it's the top 10. So we show the top 10 busiest graph links at the moment or at the time in this. When you hover over this, you'll see a way more than 10. That's because every 30 seconds, the order will change depending on what's at the top. And since we're zoomed out so far, we can't really see what's happening. If we zoom in farther, we can see how one graph, this washed the Nui, it started out low, it went high, and then it came down, and then it went off the charts, and other ones came back in. So if you're looking for, where the most data is, or if you're looking for one where there's almost no data, you can have these two choices. And the same system up here works with the drop downs. This will give you how many to return. I was returning 10. We can actually just do 3. Actually, if you just want to do 1. We can see whatever was the top one at that time. And this is a common motif that will be used in different graphs. So that is the public site. You can also go to the one-way latency, which I will show later, but if I don't get around to that, you can click on that and just kind of peruse that yourself. And again, the public metrics, you can just go there, anyone can use it. Just go to the site and take a look. For the infrastructure metrics, you have to be logged on. And again, it goes straight to the Grafana, and I'm going to go back out to the front page. I am already logged into this, but if you are not logged in, you'll get a login button there, and you go through the same login process that you did just to get to the portal or the Jupyter Hub. And we have some of the same graphs with the link information, but we also have a lot more information on this site. And we've made several different little introductory pages here that will point you to the ones, and we'll be adding more help and information with that in the future. I'll go to this detailed node one. This is the kind of one of the main of the largest set of information that comes from a single rack or a single node. So on a rack, you have the head nodes and you have the worker nodes. If you look in these names, you have HN for head node and W1 for the worker node. And you can go to any of these and you can see what's happening on the rack. We can go to one of the CERN worker nodes. You can see on this one, the RAM is at 52%. CPUs are not very well loaded. You can tell the CPU is 128 cores. It's got 503 gigabytes of RAM, so you can get some general information about that. But then as you scroll down, there's this very large list of different metrics that you can see about coming from the exact node. Everything from the network traffic to the disk IO, CPU we saw earlier. Memory status, how much is committed, how much is inactive. And on. You can tell it's a huge amount of information. And one of the problems that we have with our metrics information is almost kind of the embarrassment of riches, because you have so much information that often when people go to this page, there's like, I don't know what to do. So that's why I've shown you on that one. That's one way you can reduce the amount of information that's out there. And what we have done is we have all this information from the node exporter, and we've created other dashboards that use this information that just simplify it. Like maybe you're just interested in RAM. So we have a dashboard, you can go to that and just see the RAM. So the way you navigate the dashboards is you have a hamburger menu here, and you can go to dashboards, and this gives you a list of the dashboards. And this is can be confusing because one thing we've discovered is it's really hard to make a decent name for a dashboard. Because you can name it after the metric, but a lot of times the metric is kind of vague and unknown. Often dashboards use multiple metrics, so that doesn't necessarily make sense. And the way one person views the data is the different way another person uses it. So what we've done, instead of having just this list of names, we've added that front page where we're just kind of pointing you to information you want. So if you want just the CPU load for each node, we have a graph for that. Same thing with the RAM usage. You can also just search over here. We have two different ways you can look by filter. So there's one by temperature. So that will give you a graph of the temperature of the racks. You can also just type in temperature up there, and that will point it out to you. And you can do the same thing here anytime because this search one at the top is always active. You do the same thing for a network. That seems odd. Okay, this is going by the name of the graph. Yeah, so if you wanted to filter by tag, you'd have to come down here. And some of these are actually groups of dashboards. We have one called featured dashboards. So if you go back to the dashboard, featured dashboards. And what that is just a list of dashboards. This is a list of the dashboards that we have information for on the front page. And we may be adding more different ones. So we may add, a dashboard list of the network dashboards, all in an effort, to make it easier to find the information. So let's go back to a link traffic graph. So all these queries are made behind the scenes. You can't really look at the queries because you'd have to be able to edit the graph, and we don't allow you to do that. So you don't really know what the queries are on the graph, but what you can do is go over here and do an explore. And the Explorer will take you to the Explore page where you can actually type in your own query to get information. In this case, we just went there from a graph, so it's going to fill in the query for each that is used for that graph. And in that graph, we have the data plane in bits and the out bits. And we have them coming from the source rack and the destination rack. So we have 4 different queries. And one nice thing about the queries is they can be very simple or they can be pretty complicated. In this case, this is really just a regular expression, and we're ORing all the racks that are out there. So you can simplify this quite a bit. So if we do what we did earlier, we just want Dallas and Atlanta. Shows that. Now we're wondering how that query is made. We can go to the Explorer, and it will show you how the query is made. In this case, we're just doing the one thing, so it's a much more readable query. So the reason I'm showing this is because we have an API, and the API lets you make any kind of calls that you want, same as you can do in Grafana. You can use that programmatically. So if you want to know the data plane in bits for your slice that goes from Dallas to Atlanta, all you need to know is this, and you can use that in API to grab the information. You can also just start messing around trying to figure out what the different metrics are. This is a Explorer and it's a builder view. There's a code view where you just type in what you want, but there's also a builder view where you can select the metric, and it gives you a giant list of all the metrics. There are literally thousands of these. But if you're looking for something to do with memory, you can type in memory, you can kind of start narrowing that down. So you can see there's pages, there's inactive, there's active. Same thing if you want to see what's happening on interface, you can type IF. That will give you interface information. So you can see that we have multicast and broadcast packets. We have information about that, unicast, unknown protocols, the index of the machine, the speed of the network, and so on. Go back to our data plane in bits, because this is a simple query. You can just use the source and destination. But once you type in your metric, you're able to go over here and you can see what labels are on the metric. So let's pick a source rack. Then once you do that, there'll be an equals, and you can select the value. So now it will show you all the possible source racks that are out there. So if we collect Atlanta, we can run that query. Once we have the query, we can just run the query. You have the same time thing you can set up here. So that shows for the last hour between all these racks. Now, if you want to, you can add another one. You can select the label. We'll do the destination rack and do Dallas again. So now when we run this, we'll just be getting the information between Dallas and Atlanta. And again, once you have a query you like, you can just take this query, you can copy it and use it in the API, which I'll show you in a minute. There is also a new system that they just added in July. That's Explorer Metrics. And it is a similar type structure, but it's got more visual information and more ways you can drill down to the information. So it kind of shows you all a little tiny graph with a metric name and kind of what that metric name is looking like. So this is kind of the average of all the data plane, in and out bits. So in a way, it's not super useful, but it does give you an idea of what the information would look like. So if we use data plane in, we can take that and we can select that. Now that we've selected a metric, we can come down to the bottom and we have the overview and the breakdown. So in the overview, it gives you a list of all the labels that's used that. You can go to the breakdown. And unfortunately, I can't move my screen. So the breakdown will get a list of all these different labels that are used for getting that metric. So as we saw before, there's a destination rack. You can also find out what the interface name is. If we hover over that, you can see a list of all the interface names. Or if you want to, you can select that. And it will show you all the values for the destination name and different sets of interface names. You also go to the go to the related metrics, which is nice. The data plane in bits is based on the IF octets, and Griffioen actually knows that because it has the history of how the metric is made. It's a little bit complicated, but most metrics are fairly detailed, as you saw when well, let me show you one. So in this case, it's a fairly simple metric, but the background metric, which I should be able to get to, I guess that goes it. Let me try a different metric. So here's the dashboard that we call a rack health. And it's basically just shows you the CPU and the RAM load. So you can kind of see how overloaded or free a rack is. You can see this one in Bristol is a kind of fairly heavily used node. You can also get an idea that, CERN has 6 worker nodes, so there should be a lot available there, although they tend to use it a lot. Again, you can go to the Explore. And you see in this case, this is a memory, and you're asking for the amount of memory that is available. So this will show you the formulas being used in there, turning into a percentage. The memory available minus the memory total bytes, or sorry, divided by the memory total bytes. And some of these metrics, there's different ways to get the value, whether you want to show the available bytes or that the memory used, or if you want to use specific types of memory. And the query can get fairly complicated. But the values that it returns. Okay, I've hit a bug that I find sometimes. There's also if you just type it in, it also kind of automatically fills it in for you. Okay, so what you should get when you run a query is you'll get a graph, and this will show you kind of the information that's being returned. You can also see that information down here, and this is the JSON return. Whenever you query a metric, it will return the information as a JSON with the metric name, and then all the labels inside pertaining to that metric, along with the time series, timestamp, and then the value. You can also view that as a table, which is nice because now you have the ability to look at all the different names. You can scroll across them. You can sort by, in this case, the size that some of them have. You can sort by the value, which one is highest or lowest. And you can find the different names. Sorry, there you can see that different queries will return different information. This data plane bit, I was hoping to show you that it's made up of other ones. So this is a very simple query. You're asking for the destination rack and it returns that information. You can take the queries and you can nest them. You can do the multiplication and dividing, simple math as well as Boolean operations, and there's also sets of functions that you can use. The link to the functions, I believe, is in the notes. So let me go and show you how the API works. Too many windows. Okay, so you have a account on Jupyter Lab. You can go use this notebook. Even if you don't, if you follow the links in there, you can actually go to GitHub and you can just grab the notebook and use it from there. You don't have to be logged into Jupyter Hub or is currently not using the FabLib systems yet. But if you do have the Jupyter notebooks, you can go to Jupyter Examples 1.71. It may also be in the main, but I'm not positive if that's been updated. You go to the start here, like you did for the ones that Paul was showing you. In this case, we go all the way down to the bottom, and we have live demos and tutorials. Click on that. And this is the one that we used just a couple of weeks ago on NIT. And we have the two dashboards that are in student notebooks I was talking about are really just kind of overview of what I just told you. And then we have the public API one. To use the API token, or to use the API, you need a token. Since this is part of the infrastructure metrics, not just anyone can use it, we want to restrict it to Fabric users. Currently, we're restricting it to anyone who's a Fabric user, but in the future, we're going to be restricting that down to more where you have to be a member of a special role or a group. But at the moment, you can just use a Fabric token. Paul showed that earlier. You're logged into the portal, you can go to your experiments, manage tokens, and you can open the credential manager. And for this, we should be members of the Fabric tutorials. There's not really much that you need to input here. Once you selected that, you just say create token, and it will create a token for you. And the token is a JSON object. You can copy that file, you can download it, or in this case, all we really need is the ID token. So you could just copy this string, which is a huge string. It's usually about 2,000 characters, and paste that into the notebook. Then you go back to the notebook. In this case, one nice thing, if you're having used Jupyter Notebook bunch, if you just right click on one, it will show in the file browser. So it shows you, goes through the directory. In this case, I've already created the ID token. I downloaded it and I put it in this directory. I did that because I didn't want to paste my token up for everyone to see. But you can also just take that token, copy it, and when you run the notebook, just paste it in there to where it says none. Or if you want to, you can download the file and then put it in the same directory and it will open that up for you. And what the API calls are, is they're basically just the query that you want to run with your token in them. And depending on what you need from that, you may be able to add some time information to that. The time that it uses just comes in a standard format. I created a little Python script here that will create that time for you. This particular script just uses the relative time. If you want to know from now, past how many hours in the past, it will return that information for you. So there are two types of queries. Actually, there's lots of different queries. The Prometheus API has an immense amount of information that you can query and use to work with the metrics, but we're only making two of them available for the moment. One is the instant query, and the other is the ranged query. The incident query gives you a single value that's closest to the time that you are requesting it. So if you send the request in and you don't tell it what time it is, it will send you whatever that value is, the most recent value. If you do give it a start time, then it will go back and it will give you the value closest to that. So what we do is I have a couple examples here in both curl and Python. Using curl, you need to create the header with your authorization. It'd be fabric token with a space, then just paste your ID token in there. And then URL encode your query. So your query equals, in this case, the data plane in bits and all that information. And just being cautious that there are double quotes in here, so you have to put single quotes on the outside, that type of thing. If I go up here, I can run my imports. Grab the token. When I run the query, you can tell it's pretty quick. It goes to the metrics server, the infrastructure metrics server, grabs the information and returns it as a JSON. In this case, you can see there's the status, whether it's successful or not, that includes the data. It tells you what the result is. It's a vector. And if you look in here, we have the vector, which will have the metric name, and it will have the list of labels, and then it will have the value. And the value is the timestamp plus the metric value. In this case, we gave it a start time back in May. It's returning whatever the value was closest to May. Same thing with Python. You can use request. In this case, you set up the parameters, give the query, and then your query string. And you can run that. It returns the JSON. Add in the start time. Get the information. So the other type of query is the range query. And the range query will do what it says. It queries over a range of time, and that time can be pretty much any time you choose. If it's too far back, then it won't have that. But you can know if you know when your experiment was run, you can call up and get that information anytime. Or if you ran an experiment and something went wrong and you weren't doing any kind of metrics or studying it, then you can use that to go back and get the time to see if you could see what happened. And in this case, start value is the oldest date, and the end is when the most recent time you want to query. There is an optional step value, which I believe defaults to 30 seconds. 30 seconds is the measurement time that we use, so anything less than that will not be of any use. But if we're in a large time section and you ask for a larger step, then it will kind of interpolate the values and give you that graph. And this time when it returns, it's basically the same as before, except that it has an array of values. And you can take that array of values and you can feed that into whatever graphing system you want to use, or if you want to make pandas frames out of it, or whatever you want to do to analyze your data, you can do that. So the question is, how do you make these queries and how do you figure this out? I already kind of showed you how to do that. The quick and easy way to learn it is basically to go to existing dashboard that you've seen, pick on the graph, click on the explore, see that value, and then you can just copy that and paste it. So in this case, we go to a graph, it will show this, we copy that, and we create a query string, just put that value in there, along with the URL of where we're querying, our authorization and our string, and we can make the query. So it's very easy to go ahead and programmatically grab your information. So anytime you have a query, you can always take that and put it back into the Explorer, and you can fiddle with that. You can go to the documentation that I have linked somewhere in here for the Prometheus, where you can add functions if you want to do averaging of your values or maxing, or there's a wide variety of them. The top K and the bottom K. And then here I just have a couple examples showing you a more detailed way you can grab the information. You can do the top K, so then you can run that. And then this will tell you the link from Washington to FIU currently has the most traffic. You can do the top three, and it will give that same information in order. So then you can say the top 3 links. They're in the descending order. Same thing if you want to run an experience and you want to know where there's no traffic. You can run this and it will show you which ones have nothing. So the slowest one has nothing, which may be a little too low. Then you can go to, well, basically all these are really tiny. Some of the racks that don't have much traffic, there's still a little bit of traffic going through, so it's not ever really zero. Does anyone have any questions about any of that? That's a lot to take in at once, I guess. In that case, let me find the OWL information. Okay, I already mentioned how to get there by the link. So the OWL is the one-way latency measurement. Normally, if you want to find out what the latency between 2 sites is, you run something like Persona or something, and it will ping both sides, and then it'll kind of figure out what the average latency is going back and forth between the two and cut it in half. But what we're doing is, since we have the PTP clocks that are very accurate and are set as a basis from GPS units, we get the in effect almost an atomic clock because we get a very high precision. So all of our racks are set at the same time. One thing I wanted to mention earlier is that all the racks times are set to UTC because that's, they're all over the place. So that's the only kind of way to do it that makes sense. When you looked at you look at the time in Grafana, it will give you an option to set it to your browser time or to any other time frame that you want. So that's really handy if you're running your experiment and you're in, the East Coast. You can set it to be in East Coast, and you'll be able to tell real quick that, okay, that did that at 2 o'clock, and it's my 2 o'clock, and you can do that for wherever you are. So in general, the 2 clocks from different machines, they use NTP. They're kind of coordinated, but not super high accurately. What we're doing is using the PTP clock. And so we're synchronizing both clocks or each clock on each rack using the GPS time. So there's a very high level of accuracy. We're aiming for, I believe, 100 nanoseconds overall. One interesting about this is that this is a service that we're kind of running, but we've created it ourselves by using a long-lived slice. So we basically have a Jupyter notebook that creates sets of nodes on all the different racks that have PTP. And then it goes to work sending packets back and forth and saving that data. So one nice thing about that is that it's kind of a simple way to add in a feature. And you could develop kind of your own features and do similar type things. We're doing the one way, so you don't need to do that. But we're going to be adding more features like this in the future. Currently, we have the OWL, where we're working on a persona that will do some speed tests on different nodes. You can go there and you can play around with it. Let's see. Do Dallas the star. You can submit, so it's not a huge difference or a distance. You can see that's 17.5, and this is in I guess it's in milliseconds. That doesn't sound right. That's not milliseconds. I think it may actually be in nanoseconds. But then just look at these, because in general they're pretty much close, but occasionally they're fairly different. Like this one is 1700 and this is 10.4. So it's interesting that the one-way latency is not always consistent. That's kind of a question, why is that? And Massachusetts, Utah. Oops, is Utah up? Utah's not up. It says this Michigan to Massachusetts, and you can see it's pretty much dead on the same time. But that's another tool you can kind of look and see, something weird is happening with your packets. You can look and see if maybe one of these racks was clogged up at some point in time. Currently, we have this just where you can do a duration, and then you can download that as a CSV, which will give you a list of all the values. We are working on an API to set up for this, where you can basically ask for any time span in any set of nodes. Okay. So that's all I have. If there's any questions or comments. I guess I'll turn it back over to Paul.
Yeah, so you guys can hear me still. Yeah, so I guess that is our tutorial presentation and everything. Hope it was useful. Hopefully some people got their accounts working. If you still want to get it working, just let us know. We'll help you work through it if you tried and it didn't work. I don't have a slide for it, but like one thing, if you do like create an account, try to become a project lead and create projects, that helps us out. Look for webinars that we're doing. We do 2 every month. You can find that on our portal. I forget what the topics are for next month. Also think about coming to our events, our knit events. The next one is in March, and yeah, that's what we have. Hope everyone can use Fabric to do something useful now.